Worksheet Molarity. This whole packet is talking about the concentration of solutions. How concentrated something is means how much of a substance is dissolved into another substance. So when we talk about something as being very concentrated, we're saying that there's a lot of it dissolved into something else. So for example, if I had concentrated salt water, then I would have a lot of salt in my water. All right, so when we talk about concentration, we're talking about how much stuff is dissolved into something else. Now, one way of measuring that is molarity. Okay, molarity tells us how many moles of the solute, the thing that we're dissolving, are in a certain volume of solution. And we usually do this in how many moles are in a liter. So we're going to always use liters here for our volume for molarity. So on our worksheet here, molarity is a quantitative description of solution concentration. Quantitative, and I'll go ahead and write it down for you. Quantitative means it gives us a quantity. It tells us how much of something. So it's a quantitative description of solution concentration, and it is abbreviated with a capital M for molarity. Molarity is measured, just like we saw here, in moles of solute per volume of solution. So we're going to have moles of solute over volume of solution. And in this case, we're going to be doing moles per liter for our molarity. So when we're going to calculate these out, these four questions, we need to figure out either the molarity or the number of moles or the volume. We'll be solving for one of those. So in this case, it says to make a 4.00 m solution, this is a 4 molar solution, how many moles of solute will be needed? So if you notice, it gives you the molarity. So we already have a number here. Double check on these. Be careful that you're putting the numbers in the correct spot. So since we're already given molarity, 4 will go on the left-hand side of my equal sign. So I'll have 4.00 here, and then the equal sign, and then I can fill in the rest here. Since it asks me how many moles, my moles will be my unknown, and I'll have to solve for that. Now on some of these, it doesn't give us moles. Like on number 3, it gives us grams. So sometimes it'll tell us moles and we just plug it in, and sometimes it gives us grams and we have to do a little bit of converting before we can solve for molarity. And this is in your reading material on this molarity page. Down at the bottom, sometimes you have to turn your grams into moles. For those of you who did the stoichiometry packet, you'll recognize this, where you take your number of grams as a given, and then you see how many grams would be in 1 mole of that substance by adding up the mass of all of the substances combined, the elements combined in that compound. So if we wanted to know how many grams are in 1 mole of NaOH, we have to add up the mass of Na, O, and H. So if we add those together, we get 39.997. Since there's 1 of each of them, I just add the mass of 1 of them all together. So since 20 was my given, I put that 1 mole would be 39.997 grams NaOH, grams of NaOH on top, NaOH on bottom, they cancel out. And I do my math to find out how many moles of NaOH I have. Remember, multiply across the top and divide by the bottom. So here, since it gives you 12.6 grams of HNO3, you're going to have to do that conversion first. So 12.6 grams of HNO3, and then set up your conversion that 1 mole of HNO3 is going to be how many grams of HNO3. So you'll have to add up the mass of H, N, and 3 O's, put that number here, multiply across the top, and divide by the bottom. Since grams of HNO3 cancel out, that'll tell you how many moles you have. Remember, moles go on top of your fraction. So you'll be solving for molarity. You'll have the moles when you do this math, and you'll divide it by the volume, which is given right here as 1 liter. Now you'll also have to be careful. Sometimes it doesn't give you the volume in liters. It gives it to you in milliliters. I want you to remember that there are 1,000 milliliters in a liter. So if you're given milliliters, you need to divide by 1,000 to get your liters. So if you're given milliliters, divide by 1,000 to get liters. If you're given grams of the solute, you need to convert those grams to moles before you can plug those in as well. So make sure you have moles here, make sure you have liters here, make sure you have your molarity on the left-hand side before the equal sign, and solve for your unknown. If you do get stuck on any of these questions, however, please feel free to come ask.